Assalamu alaikum wa rahmatullahi wa barakatuh. Welcome to the course on modeling of stochastic engineering systems. The word stochastic means actually random, so we will be learning the basic tools which are used to handle these stochastic systems. So, how to model a stochastic system? So, for that, what are the basic tools, mathematical tools, which are required for it, and also we will see various applications in this course. So the basic tool, one of the basic tool that we need is the probability theory. Okay, and we will be also explaining the notion of the random variable, and we will see what are the different types of random processes, and what are the various application, how we can effectively make use of this theory in various applications. Okay, so various applications, there are wide variety of applications for this course. Anyway, we will be discussing some applications related to wireless communication systems, also something related to the power generation and the modeling, machine learning and artificial intelligence. So you know that in a wireless communication system, the signal will be transmitted by the transmitter and it will be received by the receiver. So whenever the signal propagates through the wireless channel, due to lot of unpredictable effects, your signal will be fluctuating. So you will be receiving the signal at the receiver which is completely different from what you have transmitted, and maybe some information will be there definitely if it is not too much if it is not too much contaminated with the noise signals, or if the amplitude has not varied too much. So anyway, you can see that there will be a significant change, or there will be a significant difference between the transmitted signal and the received signal, and it is because of the channel. Okay, so this kind of thing you can see in wireless communication system. Now in the power generation system, you know that in a power system the load may be changing each and every time. Okay, you know that during the night the load will be high, and during the daytime sometimes the load will be less. So the load will be varying with respect to time, and this kind of, according to that, we have to performs some task, or we have to arrange or schedule some tasks in the power generation, etc. And in machine learning and artificial intelligence, we also use the probability theory. Okay, we will come to all these things later. I hope this is clear, right? So let us first explain some of the basic notions. So what is the use of the probability model? That is the use of the probability model. Use of probability model. It helps, the probability model helps in building the system that are very efficient, that are efficient, reliable and cost effective. Suppose if we have a completely random system, random means that is, maybe we cannot suppose there is a system which is showing a random behavior. So in order to model that system, we may need the probability models, and it helps in building the systems that are efficient, reliable and cost effective. So we will just discuss the basic terminologies first. Basic terminologies. So what is a model? So a model, it is an approximate representation of a physical system. It is a approximate representation of a physical system. This is known as the model. So these are the basic terminologies that may be useful in future. Then what is a mathematical model? Mathematical model. So what do you mean by a mathematical model? It is the model which is represented using measurable properties. It is a model which is represented using measurable properties. Then what do you mean by the another model that is known as the computer simulation model? Computer simulation model. So it is a program. It is a program that simulates the dynamics of a system, dynamics of a system, and it will make use of the model or the mathematical model of the system, and it is used to the mathematical model of the system is used, and it is programmed by using a computer and try to analyze or study its behavior. Next one is the deterministic model. Deterministic model. So what do you mean by deterministic model? So a deterministic model, it is actually will give you the response of a system, or it will give you the actual response of a system by solving a set of equations. That is, these equations are coming from the model, that is the mathematical model of the system. By solving the set of equations, that is, we can predict the actual response of the system by solving a set of equations which specifies the model of the system. So this is known as the deterministic model. Now we will discuss about the probability model. Probability models. The probability models are used. These are used to explain the phenomena that exhibit the unpredictable, or you can say unpredictable variations, exhibit the unpredictable variations and randomness. So we will come to this terminology in future. For example, what do you mean by this randomness, unpredictable variations? What do you mean by this? Let us consider the temperature variation in a room. Let us consider the temperature variations in a room. So let us assume that on the x-axis we assume the time, for example time 10 a.m., maybe 11 a.m., this is 12 a.m., okay, 12 p.m., next 1 p.m., 2 p.m., and so on. Now on the y-axis we consider the temperature. The temperature in the room, suppose around 10 a.m. was 22 degrees Celsius. Now, as the time increases, the temperature may be slowly changing, and it may sometimes reach the peak, and after some time you can see it is varying, right? So this is a variation we cannot explain by using simply by using a deterministic model. That is, by using a function, a simple function, we cannot represent this. You can say that the time temperature is varying as a function of time. So the temperature as a function of time. So this is we can say that this is a signal, okay, which is representing a physical quantity. So it is a signal. However, its variation is unpredictable, or with some accuracy we can predict it by using some technique. Anyway, that we will discuss later, but its variation is unpredictable, we can say. So this is a random signal, okay. So this is a phenomenon which is exhibiting a unpredictable variation. So in order to tackle this issue, we need to study the behavior of this temperature variation in a room, for example. So in such a situation, we need some basic ideas, basic tools. So by using the probability theory, we can tackle this issue. So in order to explain the probability model, we need to first know regarding the probability theory in detail. So we need to know about the probability theory in detail. So first of all, we will discuss about the probability. So what do you mean by this? The probability theory. The probability theory, usually it deals with the averages. It deals with the averages of a mass phenomenon, occurring sequentially or simultaneously. So it will deals with the mass phenomenon which is occurring sequentially or simultaneously. We will start with a simple example. For example, the tossing a coin. So suppose you have a coin which is having, this coin is having both head and tails. Now if we toss this coin, then we may get either head or tail, right? We cannot get both anyway. So this is tossing a coin, we can say it is an experiment, okay, and the outcome of this experiment may be either head or tail, and it is impossible to predict what may be getting during this experiment. Maybe we will be getting the head, or sometimes we will be getting the tail. So in such a situation, so we can say that this experiment, that the outcome of this experiment, the outcome of the experiment cannot be predicted. So in this case, we may get either head or tail. So this experiment, we will call it as the random experiment. Now another example, we can say another example, that is rolling a dice. So what will happen, you will get, you know that a dice is having a, rolling a die, actually it is having 6 phase, that is 6 numbers, maybe that is 1 2 3 4 5 6. So if we roll the die, we may get either 1 or 2 or 3 or 4 or 5 or 6. So these are all the outcome. So these are all the outcome. So these are all the outcome of the random experiment. So all the possible outcomes are listed here. So a random experiment, we will go to the definition of the random experiment. Random experiment. So a random experiment is an experiment in which the outcome varies in an unpredictable fashion when the experiment is repeated under same condition. So even though we are repeating the experiment under the same condition, it is not possible to predict the outcome of the experiment. For example, you are tossing a coin. So for the first time, for the first trial, we can say for the first trial you may get head sometimes or tail, and in the second trial you may get sometimes head or tail. Okay, in the third trial also, suppose maybe you may get tail, maybe in the fourth trial you may get head, or sometimes you may get the tail, and so on. So it is impossible to predict the outcome of this experiment. Such an experiment we will call as the random experiment. So the different examples for the random experiments are, for example, this is example 1. Example 1 is we have already discussed, tossing a coin. And next we can see another example, that is selecting a ball. That is, suppose you are having a urn which contains some balls numbered like 1 2 3, and you are standing here and selecting and picking a ball. So possibly the outcomes, maybe the outcomes, you may get 1 or 2, the second ball, the first ball, or the second ball, or the third ball. Okay, then the another experiment you can say, that is you are tossing a coin. You are tossing a coin 3 times. You are tossing a coin 3 times, and you are observing what is the outcome. So flipping a coin 3 times, for example, maybe 4 times also. Now we consider 3 times. So possibly you may get sometimes head, or sometimes you will get head, tail, then sometimes you will get head, tail, then you may get tail, head, tail, then maybe tail, head, tail. So head, tail, then tail. So in the first, so if you are flipping a coin 3 times, for the first time you may get sometimes head, you may get head, and the third time also you may get head. Suppose in another way we can say, in the first 2 trials you may get head, and the third trial you may get the tail. So and so on. So these are all the possible outcomes you may get. So it is better to now to define the outcomes in terms by using the set theory. So now let us define. So we will suppose in tossing a coin, we have the outcomes either head, and tail. So we can represent this head and tail as a set, and this can be represented by using a set S, and we will call this as the sample space. So what do you mean by a sample space? So we will define the sample space. It is the set of all possible outcome of the random experiment. It is a set of all possible outcome of the random experiment. So in the first case, actually tossing a coin, in the first example, the tossing a coin, we have the sample space. Either we may get head or we may get tail, and now we are using a curly bracket to represent it, and we are using the notation S to represent the sample space. So usually we will be using the notation S for representing the sample space. And the second case, suppose you are rolling a dice, so you may get rolling a die, so you may get the sample space like 1, 2, 3, 4, 5, 6, any of the 6 phase you may possibly get. And the another one, for example, we have rolling a dice, and next what we have, selecting a bowl from the urn. For example, we have a urn like this, and there are 3 bowls in the urn, and we are picking one bowl. Now the sample space contain either 1 or 2 or 3 we may get. Maybe the another case, you have a urn which contains the black bowl, a red bowl and a yellow bowl, and you are picking. So the sample space may include the black, you may get the black, red or yellow. So this is the sample space. Now in order to define the probability, so we have a simple definition for the probability, that let us consider the random experiment. Consider the random experiment which is tossing a coin. Now in a random experiment of tossing a coin, we have the sample space as either head or we may get tail. So we know that the sample space is either head or tail. Now you repeat this experiment, repeat the experiment for many times. So you may get sometimes head, maybe tail, sometimes tail, maybe head, tail, head, and so on. Okay, and you are repeating this experiment for n number of times. That is, you are repeating this experiment for n number of times. You repeat this experiment. Suppose you got nh number of head and nt number of tails. This is the number of head and this is the number of tail. Then we can define something like the probability of head is nh over n. That is, you can see that this is n is very large. So this is known as this is the basic definition. Anyway, this definition is having some problem. Inshallah, we will be discussing it later. So the probability of head. So as the n tends to infinity, or we can say as we increase the number of experiment, you can see that this ratio is usually tending to a constant value. Similarly, for the case of the tail, you can see that the number of tails that you obtain in your experiment divided by the total number, then you can see that this also tend to a constant value. So this is one of the definition for the basic idea of the probability theory. However, this definition is having some issues that we will address in the next lecture. Anyway, we will define some more basic idea of the probability theory. Suppose we have a coin, we are tossing a coin, and the sample space, it is clear that the sample space is either head or tail. So we can define this, the probability of head, as you know that the probability of head is equal to 1 by 2. So how you are getting this? So this you can represent it as the number of outcomes corresponding to H divided by the total number of outcomes. So this is one of the simple definition. However, this definition is still having some issues. We will discuss it later. Now you can see that how we are getting this number. You can see here the number of outcomes which corresponds to the H. We are having only, we can say that there is only one outcomes, and there are the total number of outcomes. The total number of outcomes, we have exactly 2 outcomes. So we are getting the probability of head as 1 over 2. Now the probability of tail is also in the same way, we will be getting 1 over 2. Now what is the probability of the sample space? The probability of the sample space is nothing but, in the sample space we are having 2 outcomes, one is either head or tail. It is nothing but the probability of head, so plus the probability of tail. This is nothing but 1 by 2 plus 1 by 2, which is equal to 1. So it is clear that the probability is a number which is between 0 and 1, including 0 and 1. Now if the probability of a event, the probability of a event, if the probability of an event equal to 0, this implies that it is an impossible event. Okay. Now if the probability of the event is equal to 1, then it is a certain event. So we have studied 2 things. One is the impossible event and another one is the certain event. Certain event means it will happen with complete certainty. That means the probability is 1, or we can say it is 100%. The other one is having the probability 0. It means that it is an impossible event. So this is the basic idea of the probability theory. So we will just revise some of the things. We have studied the sample space. We have studied first the random experiment. Random experiment, it is an experiment whose outcomes will vary in a unpredictable fashion. Then the set of all outcomes, then we have studied the outcomes, okay, that is outcomes of the random experiment. Okay, outcomes of the random experiment. Outcomes of the random experiment. Okay, for example, tossing a coin, the outcomes may be either head or tail. Suppose you are rolling a die, then the outcomes may be either 1 or 2 or anything from 1 to 6. Now you can see that the outcome is having a particular property, whatever, for the examples that we have discussed. For example, in tossing a coin, the outcomes are either head or tail, or we can say the sample space are the set of all outcomes. So we have either head or tail. So if we get a head in a coin toss, we will not be getting a tail in the same experiment, same trial. So if we get a tail, then we will not be getting the head. So we can say that these two events are mutually exclusive. That is, if one happens, other will not happen. That is, mutually exclusive means actually if one event happens, if one event happens, then other will not happen. So if we are getting a tail, then we will not be getting a head. If you are getting a head, then we will not be getting a tail. Next, you know that in rolling a dice, okay, rolling a die, in this case the outcomes you may get either 1 or 2 or 3 or 4 or 5 or 6. Okay, if we are rolling the die only one time, we may get either 1. If we are getting 1, we will not be getting 2. Okay, if we are getting 2, we will not be getting any of this. That is, for example, if we are getting 1, other events will not happen. So these outcomes are mutually exclusive. And so this is, so we have studied the outcomes of the random experiment. Now we have already defined this one, the sample space. So sample space is the set of all outcomes of the random experiment. Sample space, it is the set of all outcomes of the random experiment. So these are the basic notions we have studied, and we have studied how we can define the probability in a simple way, that is the probability of a event, probability of a event A is defined as P of A is equal to the number of favorable cases of A, or cases, or we can say its outcomes, the number of outcomes corresponding to A divided by the total number of cases, or we can say the outcomes. So this is the one of the basic definition. However, this definition is lacking many things, and there are a lot of issues regarding these definitions. So we will redefine it later. So before going deeper into the probability theory, we will first review the basic ideas of the set theory. So we will review on set theory. Okay, so you know that a set. What is a set? It is a collection of objects, right? It is a collection of objects, and usually we denote it by using some alphabets, that is capital letters, like S, A, B, C, and so on. Okay, and also we define a universal set. Universal set. What is universal set? Which usually represented by U. Universal set consists of all possible object of interest. It contains all possible objects of interest in a given setting or application. Okay, so suppose we are considering a random experiment, then our universal set is the set of all possible outcomes. For example, the universal set, let us consider the tossing a coin example. Tossing a coin, then S is equal to the possible outcomes. The possible outcomes for this is the head or tail. Okay, but is it a universal set? So set yes, it contains the head and the tail. Set in the case of a random experiment. So in the case of a random experiment case, we can say S is a universal set. Now let us define a set A. A set A, we can define a set A as, or set A is a collection of objects from U, and these objects are called the elements. They are called the elements of the set A. So, and usually it is the elements are denoted by using the small letter. The elements are usually denoted by using the small letter. For example, A, B, C, etc. Another one you can say it is zeta, okay, and x comma y. So for example, we can say x is the element of A, and if x is the element of A, and we can say also that x is not the element of A, we can represent by using this. So here this indicates that is the element, and this indicate that not the element. So this is the basic idea. So we will just explain now the basic relation. So you can say that suppose we have a set, we usually use to represent the set by using the Venn diagram. So let us assume that we have a set which is A, then we have another set, let's say this is the set A, and another set we have, this is the set B, and both are actually contained in a universal set. Then we say that this is the A union B. A union B is nothing but it contains the elements of A and the elements of B. Okay, suppose example we consider, suppose A equal to 1, 2, 3 and B equal to 3, 4, 5. Then A union B is nothing but 1, 2, 3, and 3 is already repeated here, so you don't need to repeat it again. So 1, 2, 3, then 4 and 5. So this is the A union B. Next we talk about the A intersection B. So, let us consider a universal set U, and we have the set A and we have the set B. The A intersection B is the common element in both A and B. Now, you can say that A intersection B in our previous example is nothing but something is common, which is only 3. So, A intersection B. And in some cases, sometimes we do not have intersection also. So, let us assume that we have two set, this is A, this is set A, and this is set B. In this case, A intersection B equal to null set. For example, A equal to 1 2 and B equal to 3 4. In this case A intersection B equal to nothing. There is nothing here, so it is the null set. Now, what do you mean by the complement? The complement of set A, and we usually represented it by using a complement. So, you have the universal set and you have the set A. All the elements other than the elements in A, we will call it as the A complement. Let us assume that our U is equal to 1 2 3 4. This is an example. U is equal to 1 2 3 4 and A equal to 1 2. Then A complement is nothing but 3 and 4. Okay, this is the A complement. Now, we will say something about the subset. For example, we usually denote by using B or A. Okay, subset. Okay, anyway, subset, the notation usually used is like this. Okay, now suppose you have a universal set and you have the set A, and if you have another set B which is contained in A, then we can say that this is set B and this is another set A. So, you can say the B is contained in A, then we can say that our B is a subset of A. B is a subset of A. Suppose we have in another way also. Suppose we have this is the set B and A is contained in B, then we will say that A is the subset of B. Okay. Let us assume that A equal to 1 2 3 4 and B is equal to 1 2. So, you can say that now B is the subset of A. Okay. Next, suppose you have B is equal to 3 5 8 10 and A equal to 3, then you can say that A is the subset of B, right? This is the subset. This is the notion of subset. Next is the difference. That is, we have the difference usually denoted by using this minus sign. Okay. Let us assume that you have a universal set and you have a set A which is the subset of the universal set. So, all the sets are the subset of the universal set. Suppose this is the set A and this is B. Now, if you consider this particular portion, you can see that this portion is there in A but not in B. So, A difference B is nothing but the elements that are in A but not in B. So for example, A equal to, let's say 1, 2, 3, 4. Okay, then B equal to 1 and 3. Then A difference B is nothing but, you can see here 1 and 3, that is A difference B is nothing but something that so the elements that are in A but not in B, but B contain the elements 1 and 3. So the elements which are not, but the elements that are in A but not in B are just 2 and 4. This is the A difference B. Okay. The another one we will see is the, let us assume that this is the set A and this is the set B, and this is the common element in both A and B, and you can see here this is set A and set B, and the elements that are not in set A and set B, how to represent this? You know that this portion, by using the horizontal line, that is I have represented it by using the horizontal line, this portion is known as A union B, and something not there in A union B we will call A union B whole complement. Okay. So this is the another notion. The another one, let us assume that we have a universal set U and we have the A and we have something known as B here, and there is an intersection, something which is common to both A and B here. Now what do you mean by A complement? A complement is a portion which is not in A. Which is not in A means I can represent by using so this is A complement. I am using the red color to denote the A complement. Okay, these are all A complement. Sorry. So A complement, A complement. Okay, this is the A complement, A complement. So we have, I have shown the red path actually by using for represent A complement. Next I will use the another color, for example green color, to represent the B complement, something which is not in B, not in B. Okay, that is I will use the blue color to represent which is something which is not in B, that is known as the B complement. B complement, this is the B complement, this B complement, this B complement. Now A complement intersection B complement, what it is? Something not in A and something not in B, we are intersecting both of them. So you can see here A complement intersection B complement. A complement intersection B complement is the something which is common to A complement and B complement. So we will see an example. Let us consider a universal set 1, 2, 3, 4, 5, 6, and A is set 1 and B is set 4. Then this implies that A complement is equal to 2, 3, 4, 5, 6. Okay. Then the B complement is nothing but 1, 2, 3, 5 and 6. Then A complement intersection B complement is nothing but, if you, the common elements in both, what are the common elements? 1 is not there, 2 is there, 3 is there, 4 is not there, then 5 is there, and 6 is there. So if you see this thing with the previous one, A union B whole complement and A complement intersection B complement, let us see something. And in this example, actually we will calculate one more thing. Suppose we calculate A union B. What do you mean by A union B? A union B is 1 and 4, right? And we will also calculate A union B, the whole complement, which is nothing but 2, 3, 5 and 6. Okay, so you can see that these both are equal. So we can conclude that A union B whole complement is nothing but A complement intersection B complement. So we can shade the region here. You can see here, this is the part which is the A union B whole complement, and it is same as A complement intersection B complement. So we will also discuss some important things in the set theory. One is the empty set. Empty set. Empty set. So what do you mean by empty set? It is the set, it is defined as the set with no elements. Set with no elements in it. Now, next is the equality concept, that is equal sets. If A and B are equal, if the set A and B are equal, if they contain the same elements, if they contain the same elements, or we can say that if, for example, if A equal to 2, 3 and B also equal to 2, 3, then we can say that A is equal to B. In this case, we can say that A is the subset of B, that is A is contained in B, and vice versa, that is B is contained in A, both become same. So in this case, for example, you have a set A and B is here. Here in this case, A is not equal to B. Suppose you have another case, A, the set A, and if you have another one, set B on the same thing, set B, then you can see that your B is the subset of A and A is the subset of B. In this case, we can say that A is equal to B. So we will see some of the properties of the in basic set theory. One is the commutative property. Commutative property. That is, if A and B are two sets, then A union B will be equal to B union A. So this is the commutative property. And also A intersection B is equal to B intersection A. That is, the elements in both are equal. That is, the equality we have already defined previously. Next is the associative property. What do you mean by this associative property? That is A union B, that is A union B union C is nothing but A union B union C. And in the case of intersection, we have A intersection B intersection C is nothing but A intersection B. We will operate this, then intersection C. That means in the bracket these things will be operating first. So if you are uniting A with the union of B and C, it is same like you are uniting first A and B, then uniting C, and same in the case of intersection also. And another one is the distributive property. Distributive property. So the distributive property contains, that is it defines, that is it is described as A union B intersection C. You can see here we are having both union and intersection. This is nothing but A union B intersection A union C, and also A intersection B union C is nothing but A intersection B union A intersection C. And there is one of the very famous rule that we have already observed from our previous example, that is nothing but, we have already explained this, that is nothing but A union B whole complement is nothing but A complement intersection B complement. So we will call this as the De Morgan's rule. De Morgan's rules, that is A union B whole complement is nothing but A complement intersection B complement. And also we have, for the case of intersection, A intersection B whole complement is nothing but A complement union B complement. You can see both are duals. Okay, so A complement A union A intersection B whole complement is nothing but A complement union B complement, and A union B whole complement is nothing but A complement intersection B complement. So more details regarding the axioms of the probability, that is we will be discussing in the next lecture. However, we have discussed the basic definition of the probability. However, there are some issues regarding with this basic definition, and it will be dealt in the next lecture. So please click the link below to see the next lecture. Thank you. So the next topic is the statistical regularity. Statistical regularity. So what do you mean by statistical regularity? It is a notion in the statistics that the random events, that is the random events exhibit regularity when repeated enough number of times. When repeated enough number of times. For example, you know that we have a sample space. For example, tossing a coin. In a tossing a coin case, we have a sample space head and tail, and we know that the probability of head is equal to number of favorable outcomes for the head, that is 1, and there are total 2 number of outcomes, so the probability of head is equal to 1 over 2, and the probability of tail is also 1 over 2. Now suppose we are tossing a coin. Suppose you are standing here and flipping a coin. You are flipping a coin and you may get sometimes head. You are tossing a coin, maybe you will be getting something like head, tail, like this, and so on. So if you are repeating a large number of times, you can see that the if you are repeating this experiment for a large number of times and just count the number of heads and the number of tails, which is equal to the total number of repetition, which is n minus number of head. Now if you are calculating this ratio, that is nh over n, you can see that it is converging towards 1 by 2 or 1 over 2, and the number of tail over n also will converge to 1 over 2, as n is very large. Okay, as n is very large. And this notion in statistics is known as, the statistical regularity. I hope that it is clear.